The heart's conduction system controls the generation and propagation of electrical signals, or action potentials, that cause the heart's muscles to contract and the heart to pump blood. This electrical activity can be measured at electrodes placed at specific points on the skin, from which a composite recording is produced in the form of a graph. This recording is known as an electrocardiogram, or ECG, sometimes referred to as an EKG. A tracing of the overall electrical activity of the heart, resulting from the propagation of many action potentials. Let's look at what happens during a single beat of the heart and how these events are depicted on an ECG. In a normal heart, each beat begins in the right atrium with an action potential signal from the sinoatrial or SA node, the heart's natural pacemaker. The signal spreads across both atria, causing the muscle cells to depolarize and contract, inducing a phase known as atrial systole. On the ECG, this atrial depolarization is represented by the P wave. The period of conduction that follows atrial systole and precedes the contraction of the ventricles is depicted on the ECG by the PR segment, a flat line following the P wave. When the signal leaves the atria, it enters the ventricles via the atrioventricular or AV node, located in the interatrial septum. It enters the bundle of His and spreads through the bundle branches and the large diameter Purkinje fibers along the ventricle walls. As the signal spreads through the ventricles, the contractile fibers depolarize and contract very rapidly, inducing ventricular systole. The ECG's QRS complex represents this rapid ventricular depolarization. Atrial repolarization also occurs at this time, but any atrial activity is hidden on the ECG by the QRS complex. Finally, as the signal passes out of the ventricles, the ventricular walls start to relax and recover, a state described as ventricular diastole. The dome-shaped T wave on the ECG marks this ventricular repolarization. On the ECG, the ST segment depicts the period when the ventricles are depolarized. The QT interval represents the time it takes for both depolarization and repolarization of the ventricles to occur. The sequence of events just described and the associated ECG trace repeats with every heartbeat. Remember, an ECG is not a tracing of a single action potential, but an amalgamation of the many action potentials that constitute the electrical activity of the heart.